Okay, we're going to take a look at solving another polynomial inequality. So we now look here at example B. And in B, we've got a degree 3 cubic polynomial inequality. So as we want to solve that, our first step, of course, is to set up the related equation and solve it. So we want to find the critical values. And remember, the critical values are the solutions to the related equation, which will be your zeros of the polynomial, right? Or your x-intercepts, if you were to graph it, locations of those. So we're looking for those real number zeros for this degree 3 cubic polynomial. So let's go ahead and set up the related equation. So we got x cubed minus x squared equal to 6x. So drop the inequality symbol, less than equal to symbol, and let's put in a equal sign. And now as we're solving this cubic, all right, our first step, of course, is to set it equal to 0, right? So we can try to solve by factoring. So let's get everything on one side equal to 0. So we do that. We got x cubed minus x squared minus 6x equal to 0. And now with a degree 3 polynomial, we know we're going to have 3 linear factors. And one thing we know with this degree 3 cubic, we got 3 terms. All 3 of them are x terms. So our GCF, our greatest common factor, is an x. So let's factor out that GCF. So let's go ahead and bring that out of the polynomial. So as we do that, right, we got x times, well, we're left with x squared in the first term. X times x squared is x cubed. Bring out an x from the x squared term, we're left with a negative x. And we bring out an x from the x term, we're left with a negative 6. And so now we've got a linear and a quadratic factor. Well, let's keep factoring. We know this quadratic trinomial has 2 linear binomial factors, and we can factor this one easily using integers. We know we need an x and an x up front for the x squared term. We know our factors of 6, 2 and 3, 1 and 6. We know 2 and 3 can work together to make this middle term coefficient of negative 1. Right? We know that 2 minus 3 is negative 1. So let's put in there a plus 2 and a minus 3, and you can see the outer product, right, is negative 3x. The inner product is 2x. They add up negative x, and 2 times negative 3 is negative 6. So with that said, we can see our 3 zeros. That implies x equals 0. X plus 2 can equal 0, or x minus 3 can equal 0. So our 3 zeros are 0, negative 2, or 3. So those are our critical values for this polynomial inequality. So let's go ahead and write those up here. So we got negative 2, 0, and 3. And now we're going to take and set up the x line. So let's look at all real numbers x, negative infinity to positive infinity. And let's place these on here, negative 2, 0, and 3. Now as we do that, we can see now what our test intervals are going to be. So let's set up the possible solution set intervals. So these 3 critical values. Now with these 3 critical values, there are 3 zeros from our degree 3 polynomial. And since we had a less than equal to problem, we know it does equal, when we plug in these numbers, this is when it equals 0. So we're going to be including these zeros in our solution set. So as we do that, we have one of our possible intervals, we can shade it in, is all the x values that are less than equal to negative 2. All right, we have the critical numbers greater than equal to negative 2 and less than equal to 0 that we need to test all those x values in that interval. We also have the interval from 0 to 3, right? All the numbers greater than equal to 0, less than equal to 3, and then 3 to infinity. All the values of x greater than equal to 3 and less than infinity. So with that, we've got our 4 intervals, right? Those 3 critical values set up 4 intervals. Now we've got to figure out which of these make up the solution set. So we need some test values. Let's pick some easy numbers to plug in, something easy to work with. So what's the number less than negative 2? Well, we can use negative 3. Pick an integer value. We know the only integer between 0 and -2 is -1. I'm going to use -1 to test the interval from -2 to 0. I'm going to use +1 to test the interval from 0 to 3. And I'm going to use 4 to test the interval from 3 to infinity. So let's go ahead and figure out this first one. So is -3 a solution to the polynomial inequality? If it is, all numbers less than or equal to -2 are. So remember, we're going to go back to the original inequality, and we're going to plug in the -3 where we see x. So we have x cubed, so -3 cubed minus x squared minus -3 squared less than or equal to 6 times -3. So out went x and went -3, my test value. Well, let's simplify together. -3 cubed is -27 minus -3 squared, which is 9, less than or equal to 6 times -3, which is -18. So I got -36 less than or equal to -18. Well, -36 is less than or equal to -18. So that's a true statement. That's a solution. So -3 is a solution. So therefore, all real numbers less than or equal to -2 are a solution to this cubic polynomial inequality. All right, well, let's test the next interval. So how about -2 to 0? So we picked -1, be an easy number. Let's plug that in. So there's -1 cubed minus -1 squared. Is that less than or equal to 6 times -1? Well, -1 cubed is -1 minus -1 squared, that's -1, less than or equal to -6. -2 is not less than -6. -2 is greater than -6, so it's not a solution. So we can't include that interval. All right, so we have those values there. Again, numbers greater than or equal to -2, less than or equal to 0, not in the solution set. So -1, that test value failed. All right, well, let's move on. Let's go to the interval. Let's test it. So we want to test the interval from 0 to 3. And we picked that test value of 1. So does 1 work? So if we plug that in, that's, of course, 1 cubed minus 1 squared less than or equal to 6 times 1. Well, 1 cubed is 1. 1 minus 1 is 0. And 0 is less than or equal to 6. True. So that works. So we need to include that right in our solution set. And then our final interval, let's test it. So we want to test the interval from 3 to infinity. Well, we picked the test value of 4. Let's plug in 4 and see if it works. So does 4 cubed minus 4 squared, is that less than or equal to 6 times 4? Well, 4 cubed is 64. 4 times 4 times 4 minus 4 squared, 16, less than or equal to 24. 64 minus 16, that's 48. And 48 is not less than 24, it's greater than, doesn't work. So in the end, our solution set, right, we just solved our degree 3 cubic polynomial inequality. And it contains 2 intervals, all the values less than or equal to -2. Or all the values what? Greater than or equal to 0 and less than or equal to 3. So there's our solution set for this inequality. So again, now we could check that. So remember, this cubic inequality, so we hadn't looked at one graphically on our calculator. So remember, these zeros, right, a location of our x-intercepts. So again, if you wanted to, you could get a nice graph of it. So let's go ahead and take a look. We'll maybe put this one in on our calculator. Let's pull up the TI. So in our y equal button, let's graph in. Let's clear out our old problems. Let's graph in the cubic polynomial we had. Now x cubed, we have minus x squared. And then we had a minus 6x, because then we're less than or equal to 6x. So putting all those terms on one side, we want to know when it's less than or equal to 0, right? As we graph this one, we can put it on a standard window. And you can see here on this graph, when is it less than or equal to 0? Well, you can see from -infinity all the way over to, right there at our 0, which again, where our x-intercept is, right? Again, if you're looking at that graph, right? You can see that. And you can go to your table, right? If you go to your table, second graph button, you can see you got a 0 at 3, you got a 0 at 0. Again, look at those. But yeah, negative infinity to negative 2, it's below 0, right? It's less than, it's on the negative side of the y-axis. Between negative 2 and 0, right, you got positive values for your cubic polynomial, so that's greater than 0. That's not in the solution set. All right, when we get down here, now these are solutions in here, right? These are all negative numbers. These are less than 0. Right, now as we go from 3 to infinity, they're all positive, so they're not in the solution set. So yeah, you can see between negative infinity and negative 2, right in here, we got values that are negative. That's less than or equal to 0. And of course, it equals 0 at negative 2. And then from 0, right here at the origin, all the way over to 3, that's less than or equal to 0. So again, the grapher, of course, shows it to you, and you can see those critical values formed by those x-intercepts.